Here's more of the concepts about slope, thinking about what slope means with a graph, what it can tell you with a graph. So there's the definition of slope, which we had last time. Quick thing, the Greek letter delta again, remember, represents change in. So saying delta y means the same thing as a change in y. The symbol m is used for slope, usually. That's where that's from. And so these two things are just slightly different notations saying the same thing. Let's look quickly at that example from the last one where we said that at 1 p.m. a trucker's odometer was 189 miles, and at 4 p.m. the odometer was 360 miles. And we calculated the change in the distance that represented the vertical distance between the points on the graph here. And when we did that, that was 171 miles. And that's that 360 minus 189. And the change in the time was 3 hours. But what I want to point out is this important fact here, that when you do 171 divided by 3, the result is 57. That number 57 is the slope of this. You can think of that number as what would the change in y be? How much would y change when x just increases by 1? Because 57 divided by 1 is just the same as the number 57. So you can always think of slope here as what is the, if delta x equals just 1, what is the corresponding delta y? That's a really handy thing to explain what it means in a lot of applications. Like in this case, if he drives for 1 hour, it means he's going to go 57 miles. Intuitively, hopefully that's what the number 57 miles per hour means to you. And you could also see that here, if we were going to draw something that had a triangle here that had a horizontal distance of like 1 between 2 points, maybe from this point to this point, that horizontal distance would be 1. The vertical distance here should be 57. And likewise, if we draw another triangle over here from hour number 3 to hour number 4, that's a change of 1 hour and a change in 57 miles. So now let's keep that in mind, that slope is how much y changes when x increases by 1. To do this quick exercise, try this on your own. Maybe you don't even need to copy it down because that'll take too much time. But just looking at these, probably pause it here. Try to do these problems on your own. Just find the 3 numbers if you can. And when you're done pausing it, here we go. I'll show you the answers. So with this one, part A here, when delta x is 1, that's 1 there. From here to here is 1. The change in y is going from 5 up to 7, so that's a change in y of 2. This is going from 7 to 9, that's a change in y of 2. So that means the slope equals 2. And of course you could have gotten that by going straight from here all the way over here too. That would be a change of 2 horizontally and a change of 4 vertically. And so 2 is the same thing as 4 over 2, or you could just think of it as 2 over 1. Same thing. Here we're going from about 2.5 up to 3. So it looks to me like this is that change there is 1.5. So for this one, the slope is going to be 1.5 because it looks like that's how much x is going up every time y goes up by 1. And you could have also calculated that as from 2.5 up to 5.5 is 3 over 2. That's the same thing. Or if you go all the way from 2.5 up to 7, you could have calculated it as 4.5 over 3. Those all come out to be 1.5. And with this one, the difference is that y is decreasing. If you go from this point over to this point, that's a change in x of 1. The change in y here is going from 6 down to 4. That's going to be a change of -2. So I just wanted to show you this quick example so you get an idea of what slope has to do with the graph. You'll get a bigger number like 2 when your graph is steeper. But this is still positive slope because your changes in y's are always positive because you're going up. But here the change is a negative number, so that represents a decreasing relationship here. As x increases, as you go to the right, the y coordinate is decreasing. So negative slope means you're going to have something decreasing. Here in the middle, this one is not as steep. So you get a slope that is a little bit smaller because you're going up by a little bit less each time. And you could say that these have the same steepness, it's just that one is going up and one is going down for parts A and C. Here's another good example to look at. If we want to compute the slope of this line, we can do that for part A by looking at the change in y divided by the change in x. This time we can't really tell, looking at this time, what happens if the delta x is 1, if you just increase by 1. Because, for example, if you go from 20 to 21, that's so small on the graph there, I can't really tell what that vertical change is going to be. So we can't do it that way, but we can just use the same old formula. So the delta x is going to be the horizontal change from here to here. So that's going to be in the denominator there, 40 minus 20 gives you that distance between there, which comes out to be 20. And the delta y is going to be the y coordinate of that point and the y coordinate of this point subtracted. It looks like we have 600, 800. This must be 1000 there, even though it's not labeled. So if you do that to get the change, you subtract to do 1000 minus 500, which is equal to 500. And so that is represented by that vertical distance there. And so anyways, 500 divided by 20 turns out to be 25. So that is the slope of that line. Now B is asking, if delta x is 1, what is the length of the vertical segment? Well, that's like saying delta y over delta x, but I want to plug in a 1 for the delta x, and I know the slope is equal to 25, so I mean, to make that work, delta y must be 25. I'm really just explaining again the same concept I went over before, that the slope is the same thing as the change in y if x were to increase by 1.